Today's lesson is about direct variation. A direct variation is a linear equation that goes through 0, 0, the origin, on your x and y axis, which really just means that there is no y-intercept. Okay, up here, the equation is y is equal to kx. We don't have plus or minus a number. That means we are going to start at the origin. So that's why it always goes through 0, 0. Now the k is your slope still, but this is considered the constant of variation. Now direct variation, a lot of these we are going to be able to use our proportion problems. Okay, so an example of direct variation, y is equal to 5x. The way that you can tell something is a direct variation from a table is to divide your y and x values. And here's the reason why. If I know that 5 is my constant of variation and I was trying to get it alone, I would divide both sides by x, which gives me y divided by x is equal to 5. Which makes sense because 5 divided by 1 is 5, 10 divided by 2 is 5, and 15 divided by 3 is also 5. So that's what makes it a direct variation. So if you look at example 1, this one asks which of the following equations are not direct variation. Well, I'm looking right here, y is equal to negative 7x. My k value would be negative 7. There's no number being added or subtracted, so that one's okay. Same thing with answer choice B. There's no y-intercept right here, so it would start at the origin. That one's okay. But answer choice C would start at negative 2 on the y-axis. That's the y-intercept, so it is not a direct variation. Okay. Example 2. The value of y varies directly with x. Write a function that represents the relationship between x and y if y equals 24 when x equals 8. Now I'm going to start with the direct variation equation. Y is equal to kx. They gave me a y value and they gave me an x value. So I can plug that in place of x and y and finish solving for k. So my y value was 24. I don't know what my k value is, but my x value is 8. Now to finish getting k by itself right here, k and 8, there's nothing in between them, so they're being multiplied together. That means I'm going to divide both sides by 8. So I have k is equal to 3. 24 divided by 8 gave me 3. So they actually want us to write a function, so we're going to go back and take our answer, which was 3, and plug it back into that original equation. You're going to leave x and y alone. So it would be y is equal to 3x. Okay. Now I'm going to skip over example number 3 because that problem is worked the same way as number 2, and I'm going to move on to example 4. Suppose y varies directly as x and y equals 21 and x equals 3. Find x when y is equal to 42. Now this one's different because they're not actually asking me to write an equation or a function. They're just asking me to find one of my x or y values when they gave me 3 of the other values. This is when you can start using a proportion problem. So I'm going to put x over y, but it actually doesn't matter if you do it the other way around as long as you are lining things up correctly. Now these two are mentioned together, so they need to go in the same fraction. The y value is 21, the x value is 3, so I'm going to put it just like that. They said find x, so I don't know what my x is. That's the unknown when y is equal to 42. So I've got to line that up with the y value. Now I want to make this clear. This stuff over on the left, the x and y, was just to help you line up your equation. Okay. So now that we have this, we are going to do cross multiply and divide. So I've got to multiply the things that are across from each other. Well, 21 times x is 21x, so that part's easy. For the other part, I'm going to use my calculator. I've got 3 times 42, which gives me 126. So 126. From here, I need to finish solving for x because they wanted me to find x. So I divide both sides by the 21 because it was attached to my letter x. So I'm going to do 126 divided by 21, which is 6. So x is equal to 6. Okay, number 5 is the same type of problem as number 4, so I'm going to skip it and move on to a word problem. Example 6. This one says the area of an oil spill on land varies directly with the volume of the oil spilled. If a 40-gallon oil spill covers an area of 104 square feet, how many gallons of oil spilled covers an area of 195 square feet? So once again, they've given me 3 numbers in here, and they want me to find how many gallons. So I've got to figure out what we're talking about. And because it varies directly, I know I can set up a proportion problem. The 2 things that are changing, they said if a 40-gallon oil spill, so we're talking about a gallon oil spill, covers an area of 104 square feet. So I'm looking for the labels in order to set my problems up. Okay. The first one said the 40-gallon oil spill, so that one needs to be lined up with my oil spill, covers 104 square feet. So those 2 go together. Then on the other part, it said how many gallons of oil, so the gallons of oil is the one that I don't know on the second part. That's going to be my variable or my unknown. And this covers 195 square feet. So I'm going to put the 195 down here. Once you've got your proportion problem set up, it is the same thing we've been doing. You're going to cross multiply. So 104 times x is 104x. And then when I do 40 times 195, I'm going to use my calculator. That gives me 7,800. So 7,800. After this, it is still just one more step. I've got to get the x by itself, so I'm going to divide both sides by 104, which cancels out on the left. And on the right, 7,800 divided by 104 gives me 75. So x is equal to 75. Now this one was a word problem, so make sure that you're looking back at your answer choices to label this. The x was on the top, which was talking about the gallon oil spill. So this would be a 75 gallon of oil. And you can go back to the end of the question right here. It said how many gallons of oil spilled. That's why we have answered the question correctly. So example number 7 is the same idea. All of the questions on the homework assignment should match up with these examples that I did for you.